Good afternoon, dear colleagues and friends. I welcome you to the platform developed by the All-Russian Science Festival Nauka Zero Plus. As you may all know, next year we'll be celebrating the 60th anniversary of Yuri Gagarin's flight to space. That was the very first step of a human being to the unknown void. By the middle of the 20th century, humanity had accumulated some knowledge about that area, about the space which surrounds our planet. After adding some technology to this knowledge, the humanity finally managed to reach away from its habitat towards the new world, the space world. Sooner or later, this had to happen. We know almost every point on the Earth. The geographical discoveries are over, and research about the world which surrounds us has stipulated new searches. The English word research is derived from the French word rechercher, to search, and the English word also contains search. So what are we searching for by research? Since the ancient times, the most important question for the humanity was, what is being? A human, naturally, has been seen as the center of the universe. All study of the world was centered around humans. An example of this is the geocentric model of the universe, which dominated for a large period of time in our civilization. By putting a human being in a new point in space, the humanity started to vigorously seek new knowledge about that environment. For example, the question whether a human being can actively operate in that environment and live there. We can compare it to the early days of ocean discoveries when the great explorers sought for new lands. This is what happens now with space flight. A person who is said to participate in a space flight, as you may know, is called a cosmonaut or an astronaut. These two words share the second part, naut, which derives from the Greek word a sailor. That means that we continue that very task of sailing away from home shores and exploring the new areas. What are the oceans covered by the cosmonauts and astronauts? Let's see. For the majority, the word cosmonaut means a person who actually went beyond the Earth's boundaries, a person who crossed the common line. However, it would be more precise to call a cosmonaut a person who went through the special training for a spaceflight, a person who is trained to perform research and experiment in the field in which that person specializes, to perform experiments in space. A researcher cosmonaut is obviously a perfect candidate for exploring space as a new potential habitat to humanity. One day maybe this will be the truth, we will be able to do that. However, currently, pure researchers cannot afford to spend uh, many years, which is real, for training to perform just one experiment in space. As for now, a more viable model is to let professional cosmonauts perform all scientific experiments and research in space. This is how most of research is performed on board of manned orbital spacecraft. Now let's delve into the preparation and training process for manned spaceflights. The selection process has been molded for decades. The first selection included only military pilots. Now, in the latest years, it is open. The medical requirements have become leaner over the years, but still the major part of selection consists in fulfilling the medical requirements. The newest equipment which can perform precise diagnostics is used. On this stage, it's crucial to understand whether a potential cosmonaut can pass through the years of exhaustive training, stay healthy, and manage to perform one or maybe more spaceflights. This is also a base for a population research, for defining the capabilities of human body. The medical records for each cosmonaut are kept throughout the training, flight, and even after retirement. Retired cosmonauts keep being the object of this medical research. Here we, for the first time, start to view cosmonauts as objects of research, of medical and psychological research. If we go 60 years back, those times scientists couldn't tell how a space flight will affect a human body. Human body, over the course of millennia, has been accustomed to terrestrial gravity through evolution. Scientists tried to predict whether human lungs, heart, and other organs will function correctly in zero gravity or weightlessness. Another important question was whether a cosmonaut can manage a spaceflight psychologically. At the start of the cosmic era, each launch presented new opportunities for studying the capability of human bodies. Each time there were new conditions. This is how space medicine formed as a field. And it happened so that it was a medicine professional who performed first real scientific research independently in a spaceflight. The first flight did, of course, include some tests on board of the stations. However, it was the launch of Voskhod 1 on the 12th of October 1964, which was the start of a new type of research on board of manned space stations. Voskhod time for the first time included a crew of 3, Commander Vladimir Komarov, engineer-developer of the Texas Konstantin Feoktistov, and a Dr. Boris Yegorov. This had been the dream of Sergei Korolev, which he expressed in his works: engineers, researchers, doctors flying into space. Since the start of cosmonaut selection, one of the crucial part has been the fundamental aspects of spaceflight, such as the knowledge of general principles of an orbit flight, knowing the basic things about the station and the nature of a spaceflight, knowing how space environment affects the human body. This is the basic knowledge which is given to cosmonaut candidates on the basic stage of cosmonaut training. In parallel to gaining that knowledge, cosmonauts make the first introduction to the program of space research. There is a document called a long-term program of scientific and applied research and experiments for the Russian orbital segment. As part of the basic course, cosmonauts should receive basic knowledge or refresh their knowledge had acquired before of each of the fields of space research. Cosmonauts should know the terminology used to communicate with the researchers and the mission control. The objective is not making out of a pilot or a doctor, making a researchers with a PhD. However, we should note that many cosmonauts, after retiring, continue doing research. They earn their PhDs or doctorates. But at the stage of basic training, the start of the long journey towards space, each cosmonaut has to pass many exams on scientific disciplines, to visit research stations, universities. This is when cosmonauts are introduced to the scientific community, to the people who formulate the experiments cosmonauts are destined to perform. At that stage, cosmonauts become subjects of scientific space research, the people who perform this research with the hands. We would love to call these specialists researchers cosmonauts. We can say that they are the people who explore new spaces for human to use. The official documents referring to the cosmonauts still have the term research cosmonauts, and their functions include performing applied research and experiments. However, the candidates who pass through basic cosmonaut training only receive the title of tester cosmonaut. Indeed, testing space equipment at the current stage of our space technology is a big part of space program. Therefore, it's not important where you came from as a candidate, whether you're a pilot or an acclaimed scientist. First, you are trained in space disciplines as a future operator of space equipment, of complex space equipment, as a tester of that equipment. However, sending humans to space just for the flight, just for maintenance, would be a waste. We can say that the orbital station as a platform for space research and a cosmonaut as a researcher can themselves be objects of scientific research. However, initially the International Space Station, as well as the first space stations, was formed as a platform for scientific research on near-Earth orbit. It was built for scientific purposes. Just imagine having a scientific laboratory many thousands of kilometers above the Earth in zero-gravity conditions. Through one of the windows, researchers can see the Earth, the change of day and night, and from the opposite window they see sky in all of its immensity, the planets and the sun. This is a dream of all researchers on Earth. In order to ensure the work and efficiency of that laboratory, the experiments carried on board the ISS were grouped into segments of scientific research. For example, microgravity allows us to create the purest structures, purest nanostructures of organic and non-organic substances. Weightlessness helps us to manipulate with a fourth substance form, plasma. These research is included into the research program for the ISS. The ISS has its orbit on the very boundary between the atmosphere and the space. The ISS can study the processes in the highest layers of the atmosphere, such as the troposphere. Through this study, we can better understand the impact of external and internal factors on our planet, such as negative anthropogenic factors. Those are the aspects of studying the Earth and space. The conditions of a space flight, if we view them in complex, such as zero gravity, high radiation levels, and the psychological aspects of being in a confined space, allow us to model longer manned flights, for example, to other planets of the solar system. Of course, we should also maintain the health of the crew during those flights. Those are the aspects of studying humans in space. The conditions of a space flight, such as lower magnetic fields and weightlessness, affect biological objects and biological processes happening within human body. Some of these effects are positives, some should be mitigated. Those are the aspects of space biology and biotechnology. The relatively low orbit of the ISS and modern technology allow us to send cargo to the station within hours, which is crucial for conducting biotechnological and medical experiments on board. Time is of great importance here. This is where urgent cargo are used. They are mounted on board the last and taken out on board the ISS first. On the other hand, using the ISS equipment for a long time, together systems, allows us to draw from the decisions used by designers and engineers during ISS construction for designing future stations. The research conducting on board the ISS will stay on the pages of scientific journals. Maybe new generations will not be aware of this research at all. That is why our main objective is to engage younger generations in this process, to inspire their interest in exploring space, in exploring new boundaries. This is the objective of science communication, of popularizing space research. We can also define another component of space research, the international cooperation of space laboratories, the space agencies of different countries. This is one of the most important aspects for now, because during the highest political tensions, the cooperation in space has been the uniting factor of international relations. The main objective here is to combine two or more aspects to conducting space research into a united organism, despite the differences between national systems. Let's go back to our laboratories, to our equipment at the station. Our laboratory is located on board as virtually an autonomous station with a stationary orbit. This presents further limits to using scientific equipment on board the station and on its surface for scientific research. Let me have an example. For example, the declination of the station of its orbit, 51.6 degrees, and the trajectory of the flight does not cover, for example, the northern regions of Russia, Canada, Scandinavia, the Arctic, and Antarctic. Another example is that while planning an experiment, we should take into account the size of the equipment we are planning to use. As a rule, the equipment on board the ISS is placed on special equipment shelves with all the required systems already in place, such as electricity, access to transmission systems, and cooling systems, vacuum systems. Of course, we should also take into account the size of the hatch of the cargo rocket. It may happen that the equipment will not be able to be brought into the ISS. To sum up, while planning an experiment back here on Earth, we should plan in advance the ways of storing and using it on board the ISS, despite the possible differences between the sections, for example, the American and the Russian segments. Of course, cosmonauts, the hands, eyes, and ears of researchers, would be grateful to them if the work would be clear to them and easy. They would like the instructions read for using the equipment to be clear and understandable. Cosmonauts are researchers, they are interested in the fields they're working in. In this respect, more and more interest is noticed from business and commercial organizations. Sometimes these businesses, which are simply interested in space research, propose their approaches, new approaches to space research. And we have the opportunity to make more research. Space agencies of the world welcome those initiatives. They welcome new ideas of conducting the research on board the ISS. For example, an experiment on board the ISS can be conducted by any research organization, any research institute. Russian Institute SNIMASH, Central Scientific Institute of Machine Construction, invites on its website any willing participants to conduct a space experiment. Space experiments and research on board the ISS stop being available to selected few. They become available to wide scientific community while not losing their uniqueness. Those experiments are unique not because of the vacuum, the space radiation, but because the results of these experiments make life of millions of people on Earth more comfortable, more secure. The results include new materials, new approaches to design and production, new methods of disease diagnostics and treatment. However, the most important result here, in my opinion, the result of our activity in space, is the inspiration for new dreamers, new researchers. I think it will bring our civilization to a new development stage. What should we expect in the near future? The development of manned space flights brings us to the thought that soon we will pass from research in orbital flights towards the applied use or maybe commercialization of these orbital stations. This is probably a normal process, it's just a question of time. The first steps in this direction have already been taken. The first space tourists have visited the ISS. The first commercial spaceship is in development. In this respect, a question may arise. Should we fear a decline in space research? Should we fear space research being replaced with routine flights? I don't think we should be afraid of it. It is just that autonomous stations will play a bigger role in space research. The role of a human researcher is not replaced with commercial flights. Its role is just expanded towards the other celestial bodies, other planets and the moon. What's next? Next, the humanity will be preparing for a next leap, farther and farther away from the Earth. The history will repeat itself. There will be first explorers of those bodies, and the researchers will come after them. I'm sure it will happen. I am sure of it because, as Neil Armstrong put it, research creates new knowledge. My name is Dmitri Petelin. I am research cosmonaut of ROSCOSMOS. Thank you for your attention.